Hello everyone, today in this video we'll be discussing the second module of DSA, super important question from the exam point of view. So in this video we have the most repeated questions from the previous papers. Make sure you watch this video till the end and don't miss any of these questions. Before starting, please do like and subscribe, it helps me make more videos like this. And if you watch this video till the end, easily you can score more than 80% marks. This is all what you need to know from the module 2 of DSA, so don't miss any of these questions. So let's get started. The first question is, what is a linked list? Okay, that's the first question. And explain the different types of linked list with a diagram. Okay, we have to explain what is a linked list first, and then we have to explain what are the different types of linked list with a diagram. Okay, so let's have a look. So what is a linked list? A linked list is a collection of zero or more nodes. Okay, node is nothing but a box. Okay, it's a box and it's a collection of one or more box. Okay, like this it is connected. Okay, that is called as a linked list. Each node has some information. Okay, every node has some information, and every node consists of two parts, data and the address part. Okay, so every node will have two parts. First is the data part, which the information will be stored, and second is the address part. Why do we need the address? We need the address to connect the different nodes. Okay, if there are multiple nodes are present, it will be connected with each other. Okay, that is called as the linked list. There will be a connection of nodes. So the following are the different types of linked list. Okay, there are different types of linked list. First is singly linked list. In singly linked list, there will be nodes connected with the next node. Okay, just the next node there will be a connection like this. Okay, this is called as singly linked list. Second type is circular singly linked list. Here also there will be a single direction connection, but the last node will be connected with the first node. Okay, that's why it will become circular singly linked list. Okay, so we can keep on moving forward and again come to the same position. Okay, that is a circular singly linked list. Third is the doubly linked list. Okay, in doubly linked list, what will be there? There will be a bidirectional connection. For this node will be connected with this one, and this node will be having the value of the previous node as well. Okay, so there will be two address parts. So in doubly linked list there will be two address parts. One is to connect with the previous node, and second is to connect with the next node. Okay, so it will have the information which is previous to it, which is next to it. That is called as doubly linked list. And if we have used a circular connection also in that, that is called as circular doubly linked list. Only the difference is that the last node will be connected with the first node will be connected with the last node of the list. Okay, so it will be like this: the next node of this is the first node, and the previous node of this is the last node. Okay, that is called as a circular doubly linked list. Okay, this is the 4 marks question. This is the content you have to write for this question. Okay, moving on to the second super important question, give the structure and definition of singly linked list. Okay, we have to define what is a singly linked list and what is the structural definition of singly linked list, and also we have to write a C function to insert and insert the element at the beginning and end of the singly linked list, delete a node from the beginning and end of the singly linked list, and display the whole linked list. Okay, that is for 8 mark question. Okay, so here basically what we have to do, insert an element at the beginning and end of singly linked list. So SLL is a singly linked list. Here the node has a data part and a link part. Okay, data part and the link part. So whenever we create a node, there will be the data part and the link part will be connecting to the other nodes. So here the representation of singly linked list as a structure is as follows: struct node, and inside the node we will have two information. First is the int info, whatever the data we need to store. Okay, that will be stored here, and after that we'll be having a link. You'll have to write link like this, star link. Okay, and the type will be struct node itself. Okay, this is the type of the link which we want. Why we are using the struct node type? See, this is the struct node, right? This type only we are creating a link. Why? Because we are connecting the link of the type nodes, right? We are connecting it to the type of nodes, right? The nodes type. So the link type should also be struct node itself. Okay, so this is the representation of a simple node. Now insertion at the inserting an element at the beginning of SLL. So inserting an element at the beginning of SLL, that means that this is a singly linked list. Okay, this is a singly linked list which you can see, and we have to insert the element at the beginning of a singly linked list. Okay, that means we'll be creating a new node here, and this node will be connected with the existing SLL. Okay, for that what we'll be writing: first insert front int item. First we'll be taking an item. Item is nothing but the information part which will be stored here. Okay, this is what item will be sitting at. Okay, node star temp is equal to node star mlog size of node. This is the code to initialize the temp empty node. Okay, with the name temp. If temp is equal to null, temp is equal to null means temp has not been initialized. That means the storage is not available, no space is available, will exit it. Okay, means in the computer storage is not available to create a new node. Else temp arrow info is equal to item, and temp arrow link is equal to first. Temp arrow info is equal to item. Okay, temp arrow info means temp's information part should be stored with item value. Whatever item value we have passed here, that will be stored here. And temp arrow link will be pointed to first. First is nothing but this node. Okay, this will be having a pointer called as first, which will pointing to the first node. So the arrow part of this will be pointed to the first node. Okay, so this will become the first node in the list, and since this has become the first node in the list, you have to assign first to this one, right? So what we will be doing is temp is equal to first. Okay, I mean sorry, first is equal to temp. So inside first, what value will be there? The temp value. This is how we will be creating a temporary node initial to it, and we'll be storing it. Okay, next, insert an element at the end of singly linked list. Okay, we have to store at the end of singly linked list. Okay, end means what? This is the initial linked list. Okay, at the end we will be creating a temp value, and there we will be storing, means inserting the node at the end of it. Okay, so for this first, the thing is we need to create a node start temp. Okay, firstly we'll be taking an item. This item will be inserted in the information part of temp, and after that node start temp and start curve, we have to create two pointers. First pointer is to create a new node, and second pointer is to reach the second last node. Okay, this node you have to reach. For that we'll be creating another pointer. Okay, so here if temp is equal to null means no space available, exit 0. Okay, means if temp is not initialized means there is no space in the computer. Then we'll initialize temp arrow info is equal to item. The item will come and sit here in the temp arrows info part, and temp arrow link will be null, so null, this link will be null here. Next, after that is done, we have to travel till the last node here. How do we travel? Okay, if first is equal to null, first is equal to temp, means if there is no node present, temp will only become the first node. Else cur is equal to first, will be initializing cur as first, and while cur arrow link is not equal to null, unless and until the link part of current, unless and until this is not null, you have to keep on moving. Cur is equal to cur arrow link, again cur is equal to cur arrow link. So we'll keep on moving until this part becomes null. When will this part become null? Until we have reached this node. After we have reached this node, this cur arrow link will become null and will stay there itself. Then we'll do cur arrow link is equal to temp. So we'll be initializing the link part of this with temp, so that temp will be inserted at the end. Okay, this is insertion of element at the end of SLL. The next one is function to delete a node at beginning of a linked list. To delete a node at the beginning of linked list, first you have to check if the linked list is empty or not. If first is equal to null, list is empty, you cannot delete anything. Else what we will do, we will initialize cur to the first one. Okay, cur will be initialized to this one, and first is equal to first arrow link. This is first, what it was pointing to this. The first will be pointed now to the link part of first. Okay, so link part of first was pointing to this one, so first will become this one. First is equal to first arrow link. Next, free current. Free current means current was pointing to here, this will become free means this will be deleted, and the nodes will be this much only. That is deleting at the beginning. Deleting at the end means what? We have to delete this one. For that, what all we need? We need to clear the link part of this as null. For that, we need to reach till this point, and also we need to reach till this point. So two pointers we need. First is to clear off this one. Second is to make the null part of the previous one to null. Okay, so node previous current, two pointers will create, and if first is equal to null means there is no node to delete. Else if first arrow link is null, if means only one node is there and the link part of that is null, means only this node is there. In that case, what we will do, we will be just deleting it directly. Current is equal to first is equal to null, free current. Okay, and else if previous is equal to null means, in the case where there are multiple nodes, we'll create a previous pointer. Okay, and we'll create a current pointer, and previous will come here, current will go here. Next again previous will come here, current will go here, and next again previous will come here and current will be going to the empty space here. But before it goes to the empty space, we'll get to know that this is the last node, because null part of this, the link part of this will be null, so current will be here and previous will be here. Okay, so this is the point where the deletion needs to happen. So we'll do the same thing here. Previous is equal to null, current is equal to first, while current arrow link is equal to null. Okay, it's not equal to null. Okay, it is not equal to, let me make the change. Okay, it is not equal to, it is not equal to. Okay, okay, it is not equal to. While it is not equal to null, we have to keep on moving. Okay, we have to keep on moving. How do we keep on moving? We keep on moving, previous is equal to current and current is equal to current arrow link. Okay, previous is equal to current and current is equal to current arrow link. Wherever current was pointing to, previous will come there and current will go to the next one. And until and unless we reach the last node, what we will do, previous arrow link is equal to null and free current. Okay, what does this mean? Previous link part. Okay, so previous will be here, previous link part will become null. Okay, and this is current pointing to, current will also become null. Okay, got the point. So this is the code for deleting the node at the end of the linked list. Okay, next is the displaying linked list. This is also very similar. we'll have the first here, which is pointing to from where we need to start, and current will be present here. If first is null, that means list is empty, there is nothing to display. Else we'll take current as first. Okay, the first value of the node will be coming in current, while current is not equal to null. Okay, all the different nodes will be present, and in this all different nodes, first we will be pointing to current to the first node, and while current is not become null, we will display the current arrow information, and we'll move current is equal to current arrow link. So current will go to the next node. Again information will be displayed, again it will go to the next node, until and unless it reaches the null. That means it has crossed the last node. Till that point it will be doing the same thing, it will display all the nodes. Okay, so that was a code for the displaying linked list. Okay, next is write a program to in C to implement a stack of integers using singly linked list. Okay, we have to implement a stack of integers. Okay, in integers stack, what will happen? The insertion and deletion will happen at the same end. Okay, the first node which is present here, there only the insertion will happen, and from there only the deletion will also be happening. Okay, using a singly linked list we have to do that. Okay, for this, in a stack the elements are inserted and deleted at the one end. This is the thing you have to need to write. After that, to implement a stack using singly linked list, insert at the beginning node, push. Okay, and in delete at the beginning node, this is not code, this is node. Okay, pop. Okay, refer to the previous question. In the previous question we have written the code for inserting at the beginning and deleting at the beginning. Those two codes you have to write for the that will be the stack implementation. Okay, write a note on multiple stacks and priority queue. Okay, what does priority queue mean? It is a collection of elements such that each element has been assigned a priority. Okay, each element has been assigned a priority. Okay, there will be a priority, which is the more important element, which is the least important element, such that the order in which the elements are deleted and processed come from the following rules. There will be two rules using which we'll be assigning the priority. An element of higher priority is processed before any element of lower priority. So whichever is the highest priority, that will be processed first. Two elements in the same priority are processed in the order in which they have added to the queue. If two are same or priority, which one will be processed? The one which has come first in the queue. Okay, that was about the priority queue. Multiple stacks means you'll be assigning stacks on top of each other. Okay, so this is first stack. Okay, this is first stack, and after that another stack is present, after that another stack is present. Now how do we keep track of the addresses here? Addresses will be kept track as follows. M is equal to memory size of the stack. What is the size of the stack? That is the value of M. Okay, and N is number of stacks entered by the user. Suppose that I have inserted 5 stacks. Okay, so the memory size of the stack will become this whole thing. Okay, this is the memory size of the stack. If it is suppose 20, okay, I have inserted 5 stacks and the size is 20. So M is equal to 20 and N is equal to 5. Okay, so how do we calculate the starting of the second stack? How do we calculate the starting of second stack? Is the formula is 1 into M by N. Okay, 1 into M by N. This is the for the second stack. If it is for the third stack, it will be 2 into M by N. So let's consider for the first stack, second stack. Second stack, it will be 1 into M is 20 and N is 5. 1 into 20 by 5 is 4. So this is the fourth place where the next stack is beginning. 0, 1, 2, 3, 4. Size of the stack is 5 and the fourth index is the where the next stack is beginning. Like that, 2 into M by N, it will cause the starting of the third stack and so on until the end. Okay, so this is how the multiple stacks are present. Okay, the codes will be similar to the normal stack operation, beginning in the at the top and inserting, I mean inserting at the top and deleting at the top. Okay, moving on, we have what are the disadvantages of ordinary queue over circular queue. Okay, we have to explain what are the disadvantages of ordinary queue over circular queue. See, and also explain the insertion, deletion, and display operations of a circular queue. Now, the disadvantages of ordinary queue over circular queue as follows. In ordinary queue, what happens? See, the insertion happens from this side and deletion happens from this side. Okay, whichever comes first, that will be deleted first. Okay, so front is the point where deletion is happening. So now the front will be deleting 3, and rear is the place where insertion is happening. Okay, so insertion will be after the 5, but observe what happens. I have inserted elements from here and deleted the first 3 elements. Now the rear has reached the end. I have still empty spaces left, but I cannot use the empty spaces because insertion happens from the rear, right? This is the definition of queue. So in this case what we can do, in this case this is the disadvantage because there are empty spaces which I cannot use. For that, to overcome this, we'll be using a circular queue. In the circular queue, we will be connecting the this end to the starting point, so it will become like a circle. Okay, this is the starting point and this was the ending point. Now it can, rear can go here to the next node and insert it here and make use of it, right? So this is the advantage of circular queue over ordinary queue. Okay, so here only two things you have to change: a normal queue and this queue. Here what we'll be doing is rear plus one modulus size. Okay, this is the code you need to write instead of rear plus plus. Okay, instead of rear plus plus we'll be writing rear plus one modulus size. Okay, so the code is as follows: insert int item if front is equal to rear plus one modulus size, queue overflow. Okay, means if front is present here, okay, if front is present here, there is no space to insert. Rear plus one modulus size will read to this position, and if these both are equal, that means queue is full, we cannot insert any element. Else what we will do, real is equal to rear plus one modulus size. Instead of rear plus plus, we will be always doing rear plus one modulus size. Okay, in circular queue we need to do the modulus operator to reach the point where the starting also will be there. Okay, we cannot do directly rear plus plus. That is because suppose that the index is here, see the indexes 0 1 2 3 4 5. If you do plus plus, index will become 6. We cannot have a 6 index in this place. It has to reach again 0 after 5. So for that purpose we'll be using the remainder. It will always reach the starting after 5. Okay, and after that rear we have incremented, and the new place, in the new place of rear will be inserting the item. This is the insert operation. Next is the delete operation. Delete operation is also similar. If front is equal to rear means there is no element to delete, q is underflow. Else front is equal to front plus modulus size, item del is equal to q of front, return item del. We are incrementing the front value here. Okay, if suppose that we want to delete 3, first we'll be taking 3 into the item del, and we'll be doing front plus 1 modulus size. So front will be pointing to this one, and this item will be deleted. Okay, so that is how we implement the deletion operation. Next is display operation. Display operation is very similar. If front is equal to rear, q is underflow. Else we'll perform a for loop where I is equal to front plus 1 and I is less than or equal to rear, I plus plus, and print of the value of q of I. So I everywhere it will be pointing to the places from starting from the front, it will go till the rear. I will print this, I will print this, I will print this, and after this I will be exited. Okay, so this is the display operation. Moving on to the next super important question, we have write C function to add two polynomials, show the linked representation of the below two polynomials, and add and their addition using a circular linked list. Okay, so these are two are the polynomials given to us. First step is represent the polynomials. Okay, we'll be representing the polynomials. Second is we'll be adding the polynomials and representing the answer of the polynomials. The third thing is we have to write a function to add those two polynomials. Okay, so let's get started with the beginning. The first is representation of polynomial in the linked list. Okay, first to represent the polynomial, each of these term you have to represent. Okay, this is one term. Okay, this is another term, this is another term. All these terms need to be represented in the polynomial form. Okay, so each of these is called as polynode, and it will be having a coefficient part and exponent part. Okay, you know what is coefficient, right? If it is 5, 5 is the coefficient and 3 is the exponent. It is 5x cube. Okay, it is 5x cube, and this is 4x square. Okay, 4x square. So this is the coefficient and this is the the exponent. Okay, so two things will be here, and the link part will be there to point to the next node. Okay, so this will be one node, this will be pointing to the next node, and this will be pointing to the next node, and so on. Okay, now type def struct polynode, poly will be taking it like this. Okay, and polynode can be drawn as like this. Coefficient will be written here, exponent will be here, and the link part will be here. So the following two polynomials which they have given, p1 and p2, they can be represented as 5x cube, 4x square, 7x3, 6x square, 5. You can represent it like this. This is a circular linked list. Okay, circular singly linked list, you have to be careful. Okay, if they ask singular linked list, the representation will be different. Okay, circular means you have to put a link from the last node to the first node. If it is single means you will not do that. Okay, and also in circular linked list, you will be having a header node which will be just empty node. Okay, it will be just pointing to the first node here. So p1 header will be here, and 5 3 and null. 5 3 null means 5 is the coefficient, 3 is the exponent, and null means it is pointing to the next one. Okay, the last part is link part. 4 2 4 2 means 4x square. Okay, 7 1 7 means 7x power 1. 3 0, why I have put in 0? Because 1 can be written as x power 0, so this will be 3x 0. Okay, so here it will be like this. So p1 p2 both are here, and p3 will be nothing but the sum of these two. So to calculate the sum, what we'll do, first we'll find out the equal terms. Okay, the equal terms are this one, x square and x square. When they are equal, we'll add up these two. Next equal term is here, this is pi x power 0, and this is also 3x power 0, so we'll add up 3 and 5. Okay, and 7 will be remaining as such, and 5 will be remaining as such. So the same thing will be written here, 5 will be remaining as such, 6 plus 4 is 10, and 7 will be remaining as such, and 5 plus 3 is 8. So it will be in this form the final representation. Okay, Now the function to add two polynomials, it's very simple. Listen step by step. Okay, you can easily keep in mind. This is the inserting at the end code. Okay, means this is the polynomial. If you want to insert at the end, we need to insert that time this code will be used. Before that, first let's understand add polynomials. So you remember, right? P1 was a polynomial here and P2 was a polynomial here. Okay, these two polynomials we are going to add and storing into the result. Okay, result will be another polynomial. So here what we are starting is poly star poly 1. Okay, this is the first polynomial we are getting in the parameters and second polynomial, and we are creating a third polynomial result and making it as null first. Okay, so poly 1 will be poly 1 arrow link and poly 2 will be poly 2 arrow link. So the starting nodes after the header node will be taken in P1 and P2. Now what we will do, P1 is not equal to poly 1 and P2 is not equal to poly 2, means in the circular linked list what happens, we will be starting from here and moving to the next, and when we come back to the same header node, that means the linked list is over, right? So until either of the linked list is over, we have to iterate. Okay, and what we will do in iteration, three checks we will make. How many checks we will make? Three checks we will make. First is P1's exponent is greater than P2's exponent. Okay, so P1's exponent, whatever is P1 pointing to, in this case, if let's take an example, P1's exponent is greater than P2's exponent, that means it is 5 3. This is greater. Whenever there is a greater value present here than which is present here, that means this is an individual element, right? See, if the starting node will always be having the higher value, if starting node of this is having higher value, that means there is no other node in this list present which is having the same value, because starting higher itself is 2. So after 2, 3 will not come. So if 3 had to come, it had to be first only. So by this we will get a confirmation that this is the starting node, and this node we have to insert into the result node like this. Okay, then we will move to the next node, and then again we will compare the exponent value of this one and this one. If it is greater or small, based on that we will make the differences. Okay, so in this case, first we are encountering this one and this will become true. So result is equal to insert at the end result P1 coefficient and P1 exponent. So P1's node we are inserting into the result. So now result will be having 5 and 3. Okay, this is the from the P1 we are got. Okay, next P1 is equal to P1 arrow link. So P1 will be pointing to next one, which is 4x square. Okay, 5x cube is done. Now 4x square will be pointed. Now else if P1's exponent is less than P2's exponent, in that case we'll insert P2. Okay, similar to this one, whichever is greater we are inserting that. The third case is if both are equal, we'll be calculating the sum of the coefficients, and if sum is not equal to 0, we'll be inserting. If it is 0 means we can skip that term, because if coefficient is 0, the whole value will become 0, right? 0x4 0x4 is 0 only, right? So insert at the end, what you have to insert, the sum of the coefficient and P1's exponent. Okay, you can write P2's also exponent because both exponents are same only. Okay, so the result will be the sum of these two. That's what's happening in the second one. Here in the second one, what's happening, this is 4 2 and 6 2, that means exponents are same. Add up the coefficients 4 and 2 and write 10, and the P1 or P2's coefficient will be 2. That will be the next element in the result. Okay, and we'll do P1's next and P2's next. Okay, then these two will be compared. So based on the cases which we have got, we will be continuing and we'll be able to insert at the end. Now it is possible that one of them might end early. Okay, so if one of them might get early, if suppose that P1 is not equal to poly 1. Okay, if P1 is not equal to poly 1 means P1 has not ended. In that case P2 has ended. Okay, see, we came out of this loop. It means that either this ended or both ended. To check that if this has if this is still true, means this has become false, right? That's what we are checking. If P1 is still true, means P2 has reached the end. If P2 has reached the end, all the P1's coefficient will be inserting and at the end. Okay, because P2 is over, there's nothing more to compare. Whatever is remaining in P1, insert that. If P1 was over, we'll be inserting whatever P2's remaining things are, and that will be the end of this code. Okay, and let's have a look at the insert end also. How do we insert end? We'll pass the result array here and the coefficient and exponent which we want to insert. So see here what comes, the head value, which is nothing but the result value we are getting, and coefficient and exponent. First we'll create a new node, and if head is null, we'll create a new head also. And whenever we created a new node, we will be inserting the value of coefficient and exponent into that node. Okay, so that value will be inserted, and we'll be able to assign poly temp is equal to head. First temp value will become head. After that we'll be checking temp arrow link is not equal to head. Till that point means last node we are reaching, and after the last node we will be inserting the value of new node we have created here, right? New node is equal to create node coefficient and exponent. Okay, so passing this coefficient and exponent in the create node function. Okay, this is another function you need to write, but it's not compulsory. You can just write create node here, and a new node will be created. That new node will be assigned to temps link, and new node's link will become head. last node's link part should be pointed to the first part, which is head, right? So that's why new node's link is head. So the insertion was successful here. Okay, then we'll be returning head. So this is all for the module 2 of DSA, and please do like and subscribe. It helps me make more videos like this. Don't miss any of these questions, and thank you so much for watching. I'll see you in the